All women. We should talk about all women. I mean,
let's talk about all women. Let's talk about all women. Yes, I think that's a great idea. I wonder how many. Yeah. Say that again.
That's the reason we are gathered all together tonight, because of all women.
That is correct. That is correct. All women is great. So for those who are just joining us and never heard of All Women, or just recently heard about who we are and what we do, I'm just going to explain for those who are just joining us. So All Women is a platform to learn about technologies, and so we have various different classes like machine learning and AI, as well as project management, and I think we just started a programming leg as well. So we are really invested in creating the pipeline to bring more women into the technology world, especially in large companies, so that we can start making changes and making differences from within. So we are super happy to give women a platform to get into the industry, the technology industry, and that's why we are all here for. Today we have, I don't know, should we start, or do you guys want to wait a little bit?
I believe we can start. We are 22, and I will be accepting the people who is joined. So
okay. So let's get started. Well, if you guys haven't muted, if you're not, you're just joining us, please mute. And Danny, I think you can be kind of sort of the curator of this. So my name is Silvina Catuara. I am part of the All Women crew. And today we have an enormous pleasure and to have this really special speaker, and it's special especially for me because Silvina and I go way back, and we work together at Alpha Innovation, Telefonica Innovation. And actually, Silvina, I'm going to go into the personal side of the story because I think it's really relevant here, because she had helped me when I was doing research at Alpha about cognitive research in learning. And she gave me this master class. I mean, I think it was no more than 2 hours. It gave me this master class on kind of sort of the neuroscience of learning. And it was, I mean, I never learned so much in so little time ever in my whole entire life. So I'm really grateful for her help. And then what's really amazing, I am always in awe by people that have such diverse skills, right? So Silvina, the time we spent together at Alpha, she thinks in the business term. She knows how to think strategically and commercially in business. She's extremely rigorous in her scientific research. She has written multiple articles and books as well in neuroscience. But then she also understands how all of these is relevant and how they could be transferred into the applications in technology. So it's very rare that people have these diverse skills, but it's even more rare that they are very good at all of them. So we have Silvina here. She has she's going to explain more about herself, but she's going to tell us a little bit about her research. And I'm just gonna give you the word, Silvina, because you're gonna explain much better than me about your background, as well as the topic of your talk today, right?
Right. Thank you so much, Cici. You're so kind, and I remember that the explanation of learning and neuroscience, and for me it was just a tiny little thing, and it looks like for you it was such a wonderful, great thing. So thank you so much. So now I'm going to start sharing my screen, so I'm not going to be able to see all of you. Just a second. Here you are. Great. Then please let me know if everything is fine and you're seeing my screen.
Yes, perfect.
Perfect. Okay, great. Then, so thank you so much, Cici, and actually thank you to all of you in All Women for inviting me to give this talk today. My name is Silvina Catuara Solarz, and yes, today I'm going to be talking about sex and gender biases in artificial intelligence for biomedical research and healthcare. I wanted to start with a few words about myself. So I'm based here in Barcelona, in Spain, and I have a background in academic research in preclinical and clinical neuroscience. For many, many years, I have worked with mouse models of disease and tested therapies in patients with neurodevelopmental and neurodegenerative disorders. And after finishing my PhD in biomedicine, I moved to the pharmaceutical industry. And in the last several years, I have been working in the field of digital health. That's where I met Cici. And I have been involved with the development and the assessment of digital solutions for psychiatric illnesses and mental health disorders. And since 2017, I have been part of this organization that is called the Women's Brain Project, that is a non-for-profit organization based in Switzerland and is focused on identifying and raising awareness of sex and gender differences in health and disease, with a particular emphasis on mental health and neurological disorders. And it is organized in these 4 areas of work that you can see here on the right: basic science, clinical science, socioeconomic risk factors, and this 4th one that I am part of, that is emerging technologies. And the team that we are working on these emerging technologies this year, we have published an article on the topic of sex and gender biases in AI in Nature Digital Medicine, which is actually the foundation of the talk today. And here you can see some of the really amazing contributors of this paper. Actually, it's been a great team effort, and it has been led not only by people from the Women's Brain Project, but also from many other public and private organizations. And of course, before starting with the actual talk, I really wanted to acknowledge all of them for their contributions and their work. Okay, so here's the structure of the talk. So I'm going to first start with a brief introduction about precision medicine and sex and gender biases. Then I'm going to walk you through some examples of sex and gender biases in biomedical and clinical data sets, and then on technologies based in artificial intelligence. And then I'm going to share some proposals of solutions and a summary of some recommendations for both the collection of data and also the development of AI. And we will have some time for question and answers, and I will be just open for discussion with everyone online. Okay, so everything starts with this spectacular and very promising paradigm of medicine in the 21st century, that is precision medicine, that I am sure that most of you must have heard of. And the aim of this precision medicine approach is to deliver diagnosis and therapeutics that are precise, personalized, based on stratified populations and person-centered, by taking into account differences in genes, environment, and lifestyle throughout the lifespan of people. And the great value of and the impact of this approach makes it one of the most promising health initiatives in our society right now, not only because of its high potential for efficacy, but also because it has changed the perspective towards the patients. In this paradigm, patients are no longer passive recipients of healthcare, but rather proactive and participatory agents in their health journey that can contribute with their health data, and also they can make informed decisions about their own health. This is the precision medicine approach in general is a very, very ambitious approach, and it requires a deep understanding of health at very many different levels, from the genes to physiology, and also in relation to behavioral and social dynamics of the person, because actually health is not only the absence of disease, but rather a state of complete physical, mental, and social well-being of the individual. And well, in the recent years, there has been a great progress on the understanding of human health and its diversity. But I mean, even if there has been a great progress, there is still a great gap that needs to be addressed. And this gap is related to the sex and gender differences in health and disease. So there are, in this area and this topic, there are plenty of unexplored aspects, which, if ignored, if left neglected, they can not only lead to suboptimal health practices, but also to discriminatory outcomes. In fact, it has been shown that there is robust evidence that there are sex and gender differences and other, together with some other biological and sociocultural aspects in the prevalence, the age of the onset, the symptomatology, the prognosis, and the effectiveness of treatments in a number of clinical and subclinical conditions. Specifically, sex and gender differences have been reported in chronic diseases such as diabetes, cardiovascular, neurological, and mental health disorders, cancer, just to give a few examples. And despite this, most of the biomedical research and clinical practice is done in a way that is relatively agnostic for sex and gender. The good news is that in the last decades, there has been a great progress on the development of different types of technologies based in artificial intelligence that can help us understand inter-individual differences in disease, not only in relation with genetic and environmental factors, but also in relation with sex and gender. And these technologies are going to represent the key aspects for the development of precision medicine approach. Now, the thing is that you can argue that these artificial intelligence technologies can act as a double-edged sword. And what I mean with this is that on one hand, if these technologies are developed without removing biases and confounding factors, they can magnify and perpetuate existing sex and gender inequalities. And on the other hand, if designed properly, they have the potential to mitigate inequalities by accounting for sex and gender differences in disease and using this information for the generation of more accurate diagnosis and treatment. Knowing this, everyone would agree that the ideal AI systems for healthcare would avoid discriminatory biases and enable the differentiation among individuals for their vulnerabilities and their response to treatments. Nevertheless, despite the huge advances so far, most of the biomedical AI technologies do not account for bias detection, and the design of the majority of algorithms ignore the sex and gender dimension. So let's talk a little bit about biases in biomedical data. There are two main categories of processes where these biases sneak in. In blue, here we have biases that appear as part of the generation of the data, which can reflect a previous historical bias in the world or a representational bias due to the sampling process, or a measurement bias if the instrument that we are using to quantify a parameter is more prone to a certain type of outcome, for example. Then in orange, we have biases that appear as part of the building of the model or the implementation of the model. For example, for a particular development of a model, the data set is split into a training and an evaluation set that can add an aggregation bias. In addition, other biases can be involved with the evaluation of a model when comparing it to a benchmark dataset. And lastly, the final model generates an output in the real world that can pull some additional deployment biases. All in all, many of the things that I just mentioned can be summarized in this phrase that is commonly used, that is garbage in, garbage out, meaning that if you're using biased input, you will likely get biased outcome from the model. But not all biases or differences are bad. Actually, in the context of precision medicine, the differential consideration and treatment of specific biomedical aspects is a necessary course of action. Therefore, we have defined sex and gender biases and differences in a desirable and undesirable way. And these differences and biases that are desirable or undesirable can be present throughout the generation of biomedical data and the implementation for their clinical use. For instance, an undesirable bias would be to collapse all sex and gender categories into a single one in studies using animal models or in clinical trials with patients. Or another example would be to prescribe a one-size-fits-all treatment despite differences in mechanisms and symptoms across sex and gender that can lead to some secondary effects in some of the groups. On the other hand, some desirable differences would be to account for sex and gender when designing biomedical and clinical studies leading to representative samples and to prescribe a tailored and more effective treatment accounting for sex and gender differences. Now, moving to some concrete examples of sex and gender biases in biomedical, clinical, and health datasets. One very relevant example of undesirable biases is found in the generation of preclinical data with animal models. For many years, animal research had been done without considering the sex factor, and most of the studies were performed with male mice for convenience, as you can see in this plot on the left in the blue bars. But now we know that actually there are very critical differences between male and female mice in their physiology, and in fact up to 73.3% of mice behavioral phenotypes depend on sex, as you can see in this other plot on the right, that is a work from the International Mouse Phenotyping Consortium. Because of this, in the last years, more studies have started including both male and female mice, but there is still a long way to go to ensure that this data is collected in a representative way. In terms of clinical trials with patients, when it comes to representation of men and women, there are also undesirable biases. In this study, done by the FDA of clinical trials in 70 countries, we can see that women are still less represented than men, and this happens in therapeutic areas that are not specific of sex, such as diagnosis with medical imaging and rheumatology. And although representation of women has been increasing over the last years in clinical trials, regulatory policies will be required to ensure that sex and gender parity is in biomedical and clinical studies granted. So the consequence of these undesirable biases is a worse outcome in the effectiveness of drugs in women, and sometimes it is leading to deadly secondary effects. In this table, you can see several drugs that have been withdrawn from the market in the US because of their adverse effects, and you can see that many of them had greater health risks for women. Another area where we encounter early sex biases corresponds to digital biomarkers. These are a novel way to assess physiological, psychological, and behavioral indicators of health through data derived from digital devices such as smartphones or wearables. And the neurological and neurodegenerative disorders will particularly benefit from these digital biomarkers, since they are able to assess the data in a continuous, ecological, and objective way. And thus, this can be used for the detection of very small fluctuations in daily performance. Despite the progress that has been made on the digital biomarkers during the last years, sex and gender differences have not been examined properly yet. And here there is, for example, a study using digital biomarkers for Parkinson's disease that only had 18.6% of their sample population being women, as compared to 81.4% that were men. As a consequence of this, it can lead to a more accurate detection of symptoms that are more frequently manifested in male patients with Parkinson's disease as compared to female symptoms. So this is something that is important to consider for future studies. Moreover, there are, on top of these biases that I just mentioned, another type of undesirable bias, that is the digital divide. This consists of an unbalanced access and usage of digital devices among people, specifically here in terms of different sexes, but it has also to do with different ethnicities and different economical and sociocultural backgrounds. In fact, it has been shown that in some countries of South Asia, women are 26% less likely to own smartphones compared to men, which creates uneven data sets that promote a misrepresentation of real-world digital biomarkers. Therefore, efforts into the identification of sex and gender differences in these digital biomarkers will lead to more accurate indicators for prevention, diagnosis of disease, and also for the more effective treatment monitoring. Okay, so now moving into actual other technologies based on AI. So the first technology I am bringing up here is big data analytics. It consists of a number of techniques to collect, organize, and examine large amounts of data, and includes infrastructures, data-driven algorithms, and AI solutions to identify hidden patterns that can be either for correlation or causality relationships between variables. These are very powerful tools in the biomedical and clinical settings, as big data analytics has the potential of providing deep insights on health and disease based on different types of data like genomics, proteomics, geolocalization, social media, longitudinal data, etc. But as its names indicate, it heavily relies on the data. So it is heavily exposed to the risk of including and perpetuating sex and gender biases. In particular, genomic data is one of the largest biomedical big data that is produced together with imaging data. In recent years, the growing improvement of sequencing technologies has led to the accumulation of more and more DNA sequences that are available in dedicated repositories. It is estimated that in the near future, we will reach a point in which we will have sequenced all possible genetic variants observable in the human population. This process actually has already started through different initiatives, such as the efforts that are being made in Europe on human genomics. And although some very interesting insights have been extracted in relation with sex, genetic variances, and health, the equal representation of men and women will need to continue to be ensured, as well as other diversity of ethnic differences, so that the conclusions that are drawn from these, for example, genome-wide association studies are not biased towards the middle-aged white men with European ancestry that is very usually more frequently represented in these data sets. Another very important technology for precision medicine is natural language processing, which consists of computational systems aimed at understanding and manipulating written and spoken human language for processes like annotating documents, detecting positive and negative sentiment in texts, translating one language to another, recognizing voices and maintaining a conversation, etc. Very popular uses of natural language processing is the extraction of biomedical knowledge from electronic health records, chatbots and virtual assistants like Alexa, Siri, and Cortana, for example. And in the case of natural language processing, sex and gender biases reside in the way that the information is described. For instance, a machine learning technique called word embeddings is used to convert words into vectors of numbers. And these vectors are created by looking at the words that are frequently present in the surroundings of the target word, meaning that is based on the context of words. Then imagine, like, if there is a bias in a text that can exist, for example, in a tweet, in social media, this bias would be embedded in the vector. And for instance, words like nurse and caregiver are in general more frequently used in a context of the feminine domain, and words like doctor or manager are used in a more masculine context. And in this plot here on the right, I'm bringing you a study of biases in NLP that shows that there is a clear correlation of words associated to the female gender with the actual jobs that are more generally occupied by women in our society. And what this means is that word embeddings are somehow a mirror to the world, how we perceive it and how we talk about it. And therefore, this technology has a high risk of perpetuating existing biases. Another relevant technology with great potential for health applications is robotics. Robots can be used for different healthcare assistance functions, and they can have a more or less explicit gender appearance, which can have an impact on their effectiveness. Furthermore, on top of their appearance, the appearance of the robot, the sex of the person that interacts with the robot is very important, especially in those applications related with healthcare. For example, it has been shown that some robots have been used to alleviate the emotional states of children that are hospitalized. And here you can see in the plot on the right that robots, toy robots, like the one on the picture, had higher efficacy with children to reduce stress in comparison to an avatar in a phone or a traditional plush teddy bear. But when applying this type of robot interventions at hospitals, it is also important to consider the differences between girls and boys in their acceptance to these robots, and how these differences can have an impact in the efficacy of the therapy. In this particular study, that is here on the right, you can see how, in fact, the girls were more prone to accept robots than boys. So here are a few proposals on solutions. What do we do with this? So one solution to avoid sex and gender biases in machine learning is to pursue interpretability and explainability of the models underlying all these technologies. So among the different types of algorithms, Some are more explainable than others, meaning that in some algorithms, it is easier to identify the reasons why certain outcomes have been achieved. For instance, while decision trees are relatively more transparent in terms of the rules and the variables that lead to a certain decision, deep neural networks operate more like black boxes, and their complexity makes them unintelligible for humans and not easy to explain. But actually, this depends on the domain of applications. For example, in the case of deep neural networks for image recognition, it has been shown that it is possible to extract what the model was learning in each of the hidden layers, making it more interpretable. And you can see here, like first in layer 1, they're just more like abstract forms and shapes, and then other more recognizable elements appear, like a nose and so on. And at the end, they are more like face features. Another solution is to use available toolkits for bias detection and mitigation. Here, this one is one from the Chicago University. And here, this one is another one from IBM. And as you can see, these type of platforms allow you to explore different type of approaches just to identify if there are possible biases both in the data sets and also in the computational procedures. Another very important solution is to raise awareness of these biases and create policy regulation to ensure ethical AI. This here is a report that was recently published by the European Commission Expert Group on Gendered Innovation, which does a great job in throwing some light on the subject. So finally, some of the recommendations, both for the collection of the data and the development of AI, that actually can be summarized in these 4 key points that we have here. First of all, to distinguish between desirable and undesirable biases and differences, and ensuring representative data. Also, to raise awareness of the risks associated to biased data and algorithms, to incentivize explainability and interpretability in AI models, and lastly, to prioritize ethical principles at every stage of technology development to maximize population health. I also wanted to mention that at the Women's Brain Project, we are about to complete a book that is about the same topic that we are going to publish early next year. And we are going to have a hackathon on sex and gender differences. So everyone interested is welcome to join and can send an email to hackathonwbp@womensbrainproject.com just to sign up, and there will be more details to be shared. So thank you so much for your attention. Now I'm going to stop sharing and happy to take questions and open up for discussion.
That is absolutely fascinating, Silvina. Thank you so much for sharing. We're going to be taking some questions. I personally also have a couple of questions to ask, but I don't want to hog the microphone. So let's see if anybody have questions. You can either post them on the chat, or you can just unmute yourself and yeah, take the stand. Let me see if there's anyone who wants to ask any questions. If not, I'm just going to go ahead. You guys can be second. No. So here's my question. My question is, you've mentioned that there are many bottlenecks throughout the whole entire process of like data collecting, technology adoption, all the way to the digital divide. I mean, there are many obstacles in arriving to equality. We're not even talking about equity. We're talking about equality here. How do you, but on the other hand, there are already massive amount of data that is somewhat useful, right? So how do you go from one end to the next? How do you find the medium, making, I guess, taking advantage of the existing data, knowing their limitations and their biases, but still, I guess, extract insights from it, and then perhaps, or either we do the study or we collect the data, or is there some kind of a process so that not all is lost?
Sure, absolutely. I mean, I think that not all is lost for sure. And I think that, as you mentioned, like the very first step is to make sure that the data that you are working with is representative of, in the very beginning of both sexes, not to talk about all the gender spectrum that is much more complicated. And if it's not representative, if it's not balanced, then you have to play around with the data just to select the data in a way that resembles at least the both sexes. You will have to give away some of the data points. You will have to have a smaller sample, but you will have a more representative data set. That would be my take on it. And actually, so I come from, the biomedical, academic research. And actually, there are so many studies that are being performed in a way that they are not balanced. So I would, start from the very beginning and ensure that what we are playing with is proper data sets. Then I would say that maybe there's another layer of complexity that sometimes, for example, going into this data set of the word embeddings, if we see the frequency of job occupancy between men and women, the data that exists and the data that is available, it resembles the world. So what is possibly biased is maybe at that point not the data set itself, but society. So at that level, we are working with a much more complex situation, but we will need to actually follow our ethical and our moral principles and reflect on how these confounding factors can exist within the data, and then to correct these algorithms so that the outcomes are not having these confounding factors.
Yeah, so as a scientist, can you tell me a little bit about how do you, let's say, I find a piece of research super interesting and I want to dive deeper into it, but no access to the data, I don't know their process. How do I go about assessing whether the data is fair, whether the model is fair? Is there some kind of a protocol that we have to, this type of assessment can be made?
So I would say that everything would depend on the type of data, right? Like what it is that you are addressing, what is your research question, and why are you collecting that data? If we start with the animal models, it is as easy, I mean, there's no protocol, it is as easy to ensure that all the studies that you are doing, whenever it makes sense, right? Because there are also some biological mechanisms that are not related with sex and gender. We need to know this, and we need to acknowledge that this is sometimes the case. So it's a matter of considering the object of study, the object of research, what it is that you are doing your research on, and ensuring that at the very beginning there is a representation. I go back to the first answer, I believe. So once that is like checked in that box is checked, you can dig deeper and then continue asking about representation of other more like minority groups that may or may not be represented. But to my knowledge, there is no like single protocol, like one for all, that should be the one to follow.
There's also something super interesting, because in your title, it says, I'm hogging the question. If anybody have questions, just post it on the chat and I'll give you guys the mic. But I really want to know, in your title, you specifically said gender and sex, right? So there's a differentiation of sex, which is, and I'm going to jump in and try to understand this. Sex as in biological sex, as in we're born into that particular label. And then there's the gender, which is a social construct in a way, right? That is and that is increasingly being adopted, and for some even dynamically change, throughout their life, right? They could be identifying themselves as a certain gender when they're a certain age and then change accordingly. So I can imagine this could be a massive headache, right? As we are adopting, different data collecting paradigms. How do you see this transforming in the future?
Yeah, absolutely. I mean, in the very beginning, I agree with the definition that this is something that it is also explained in the paper, and it is really nicely explained in this report that I mentioned from the European Commission expert group on gender innovation, like this differentiation between what it is sex, that is a much more biological and based on your chromosomes, right? Either you are an XX or you're an XY. Sometimes there are these intersex individuals that can be an XY, but these are rare and exceptional. And then there is gender that, as you said, Cici, it has much more to do with the identity, and it has much more to do with your socio-cultural inheritance, the exposure of the environment and all these things. And yeah, I definitely agree with you. If we add into the mix all the different spectrum of gender and the different identities and so on, as they are so embedded with culture, this can be eternal. There are so many multidimensional variables. This is a space that it can be very, very complex. So my take on this, it is always to start with the research question. There are some of them that actually they have not that much to do with gender, but they have everything to do with sex. Gotcha. So I would say that, as a whole, and this is like a very large, let's say, research line, that there are actually several centers across, the whole world that they are doing research on this. They start with sex. And once we have sort of conquered sex differences, then okay, fine, you can increase the variability, because gender has a lot to do with behaviors, and behaviors have a lot to do also with health. So for sure there will be connection, but I have to say that this is not always the case.
Yes, super interesting. I'm going to pass the mic to Caitlin Morse, who has posted a question. Go ahead and, go ahead.
Hi, Silvina. It's been many years. Thank you so much for this presentation. So I work in medical devices, and one of the things that we see a lot is you talked about desirable versus undesirable biases. And we see frequently, you talked about how sometimes you're representing the real world as it is today, and in other cases you want to understand the balance of the aspirational situation, right? And so what we see quite often is that a desirable bias in the original data set for the specific purpose it was intended, that data set then becomes public, and that data set then gets reused by other people who want to explore other things but don't necessarily have access to that same data set. And so what was a desirable bias in the original data set becomes an undesirable bias in the secondary use of that same data set. So is that something that you have seen? And kind of along those same lines, when we look at EHRs, often, and this has been talked about a lot in the femtech space, that women's misdiagnoses are not always identified, right? So it takes women 6 times longer to get a diagnosis on a rare condition, and women are much more likely to be referred for medical, for psychological evaluation rather than for anatomical treatment. And so there's these kind of elements to the bias that maybe for the original population were helpful, but then become unhelpful for secondary. How do you see that, and how do you approach that problem?
Yeah. So thank you, Caitlin, so much. Actually, it's really, really nice to see you. We met, I was doing my Erasmus in the UK. That's when we met, like, I don't know, tons of years ago. And this is a really, really interesting topic, Caitlin. And yeah, I've seen that. What you're mentioning is that a bunch of data actually is collected for a specific purpose with some interesting and desirable differences in mind, but then they are not available for other topics of research, and then they become obsolete, or they cannot be used again. And yeah, I've seen this, and actually the reason why this is happening and sometimes it becomes an obstacle is because of these new regulations, these privacy-related regulations. And there are ways in which this can be passed. These obstacles can be passed, and it's by the anonymization of data in some cases. But yeah, I mean, I don't really have a solution, unfortunately. I know that there are lots of data sets collected in many different countries in the world that could be, be open source, open data sets, and right now they are not. And sometimes it's because of this consensus, this consent that the users or the patients are given that are for specific purposes, and they are locked for other research.
And sometimes it's monetary. Sometimes there's economics involved and as the value of data becomes more and more recognized, we're going to run into that more and more, right? And so we find also the labeling efforts associated with that data is very labor intensive, right? So we all know Facebook is paying for whole factories worth of people to identify what is inappropriate content. If we apply that in the medical space, we work with CTs that are unlabeled. Well, having a radiologist label a CT is an expensive activity. So getting already labeled CTs there's a real cost associated with it. And so if you publish that, make that data public, then recovering that cost becomes a challenge. So there's a lot of different layers to.
Yeah. Definitely. In some cases, data sets are open just for research purposes within universities, but they are not open for companies or startups whenever there are some economical interest involved. Yeah, definitely, it's true.
I think Nina has a question as well. She posted it in the chat. Do you want to unmute yourself, Nina? I will go ahead and read it. Okay, so she said, we're using more and more AI for decision making in many areas that have direct effect in people's lives. Is it enough to have, good results or more explainability in some models, as you name, for example, image recognition, to translate these prediction text to many other types of decisions if we still don't understand how the model are given its results? This black box characteristics of AI can't be the perfect landscape to manipulate results, ? And she continued to say, you talked about digital biomarkers that are generated through, for example, a device, and social media activity. Is this research today done without users' knowledge?
Right. Yeah, so I think that the key aspect of Nina's question is in terms of the explainability and how the general AI models that are, working in our daily lives, they are black boxes, right? So I think that the reflection is sometimes it doesn't really matter that much whether we understand how these algorithms work or not, because as long as they are precise and they are working, like, I don't know, just the one idea that is popping in my mind is this example of playing Go, right? This algorithm that became so popular a few years ago that it was, playing Go with, oh my God, it was amazing and it worked. Nobody really understood how it worked, but it worked, but it was fantastic. Then in terms of, algorithms that are recommending therapeutic interventions, we need to understand how they work, because if they are not right, we are putting our lives at risk. And then there's a whole liability and, more related with legal aspects, who to blame and who's responsible of all these things. So the last part on digital biomarkers, what is exactly what you're asking? Fine. So if these studies in terms of digital biomarkers are used with users' knowledge, so again, is somehow going back to the aspect of privacy of the data and so on. So My answer is there are some specific studies that are performed on discovery of digital biomarkers, like the one that I presented on Parkinson's disease, that even if, I am showing, let's say, its limitation because of the sex bias, this is a great study, and this is, for me, this is the future. While we are doing this type of studies on digital biomarkers, we are going to really gather the data on health and disease transitions. So these are beautiful studies. These type of studies, actually, they are done with full consent of patients and users, and they are participating in these studies. They are actually based not only in passive data that is collected from the phone, but also from active data. So the patients are requested to do some tasks, to do some tests on the phone. They have to run like a small exam, like with their fingers and their footsteps and stuff like that. So they know that they are going through the whole thing. Then there's other thing, that this data scraping, for example, from Twitter or other social media, and many times these are completely anonymized, and many times people don't know. These are not digital biomarkers per se. These are more like
gray area, right?
Sentiment analysis type of thing with NLP. But I wouldn't say exactly digital biomarkers. And these people really know. We may tweet now something after the talk, and maybe that tweet is going to go somewhere. Like, people on Thursday evening are happier. Or
I actually have one more question. You talked a little bit about digital therapeutics. You talked a lot about digital therapeutics, and I can also see, kind of this next stage of this, or it's already happening, which is digital pharmacy, right? Using your devices as a form of medicine. Are there already policies in place in treating it in the same level of rigor and regulations for that type of intervention?
Absolutely. I mean, these are, I would say, they are kind of morphing over time. And, this is like a bit of the far west of regulatory aspects of digital therapeutics, because it's so new. Everything is changing. These are software as medical device, both for diagnostics and for therapeutics. For example, in Europe, there are a number of regulations actually that they are expected to change in 2021 soon. There are a number of requirements in terms of the demonstration of efficacy. Like if you say that you have a digital therapeutic for ADHD or something like that, you need to show that compared to a control group, there is an actual efficacy, so there is an actual improvement over time, and that this improvement is being sustained over time. So there are a number of requirements. You have to validate the solution, the software, and so on. But still there are some changes, and everything is moving. And I'm not also an expert on regulatory aspects, but for what I know, this is something that will increase a lot in the coming years.
Yeah.
Really back to what you were saying about understanding the different layers, because that's the part that the regulatory bodies are struggling with the most, is they are seeing AI as that black box. And so they're saying, okay, well, what are the layers that got to that decision? You have to actually be able to validate at each layer that it's performing consistently. And as software as a medical device, regulatory really is struggling to understand these same concepts that you're looking at for bias.
Yeah, the government is, still struggling with like Facebook. Yeah. So I can't imagine them having any, deep understanding on how this will impact and how, all these secondary consequences. I'm going to ask one last question. I want to jump into the future a little bit because, being a futurist, of course, I want to talk about the future. But let's talk about the more invasive type of neurotech. Let's talk about Neuralinks. What are your thoughts of, this technology is being used in the near and far future, and what kind of impact would it have?
So you're mentioning Neuralink.
Yes.
Right. Well, I'm really passionate about all these type of neurotechnologies. Actually, in the coming book the one that I mentioned that we are working on together with Women's Brain Project, there will be specific chapter on neurotechnologies and, you know, differences in deep brain stimulation and brain-computer interfaces and so on. I really believe that they have a lot of potential, especially for healthcare application. I think that there is like a segment of, you know, more like the industry, you know, setting the companies that actually they are interested not only using it in the healthcare area domain, but also in the healthy population.
Mm-hmm.
In that regard, my feelings are that, you know, it can become really, really tricky when it comes to invasive technologies, and I still don't see it, but
Who knows?
See, yeah. I
Who
mean,
knows? Who knows?
I would be very interested in taking a look at the technology itself.
We need to have a second meetup to talk about this future technology. But for today, I think we are wrapping up. I want to thank you very, very much, Silvina, for, you know, sharing your research with us, and thank you everyone for joining us, and Danny, and I know Nuria, you joining, who organized today's talk. And thank you everybody, and we'll see you guys in the next meetup.
Thank you, Silvina.
Thank you, my pleasure. I love the whole thing. Thank you so much for the invitation, and it was lovely to see Caitlin.
And even our website, in case you want to know more about All Women, just don't hesitate to visit us. Thank you so much for joining.
Thank you.
Bye everybody.
Bye.
Silvina, we need to talk more. You and me. I will text you later. Mwah. Gracias. Ciao, ciao.
Bye.